Hey, Jeremy.
Hey, Jimmers, how are you?
I'm well. How are you?
Hanging in there, brother. I can't hear the volume on that.
No. I'm not playing that. I'm using my camera
Okay.
as my webcam. I bought set in my home theater here. It's a higher quality camera. That's all.
Gotcha.
How you doing?
Yeah, like I said, hanging in. I had to do a training for Pennsylvania Rural Water yesterday. I had 24 guys show up.
All right, we got a couple more minutes left here, guys. Probably a couple more people coming in. I got 9:58. 9:59. We want to thank everybody for coming in and joining us today. Hopefully, some of us are not too buried into too much snow. My name is Jim Flint. I am the upstate New York representative for Eastcom Associates. We have several members of our team here on the call as well, including Jeremy Somerville, who's going to be giving our presentation today. He's out of our Pittsburgh office. We are going to just talk a little bit about a little housekeeping here. Please leave yourself on mute during this presentation. If you do have a question, there's two things you can do. First, you can raise your hand. What you do there is just click on the bottom right. There should have an option there that says raise hand. I'll be monitoring the meeting, and if I see that, I'll just call on you, and then you can unmute yourself and ask your question. Or you can simply type in the chat feature right there your question, and we'll get to it there as well. But please just leave yourself on mute for the courtesy of the other attendees. This presentation shouldn't take too long here on utility mapping solutions that are out there in the world for you. With that being said, I'm going to hand things over to Jeremy Somerville.
Thank you, Jim. Again, welcome everybody. I appreciate you all coming out to listen to this presentation. So today we're going to be covering utility mapping solutions. Again, I'm not going to take a whole lot of time, but it's probably going to take about 30 minutes. What I do want to cover with you guys are some basics. So my contact information is on the left. If you want to contact our corporate office, that information is on the right. So feel free to jot that down. If you have any questions you don't feel like asking during this presentation, you can reach out to us afterwards. Okay, so we have to cover some fundamentals for GPS, or what we call GNSS. So there's a big difference between GPS and GNSS. GNSS is all of the constellations. So there are many constellations out there that you can use for mapping purposes. So when you say GPS, it's the US version only. When you say GNSS, it's all of the constellations. Now, for all of the constellations, you have the satellites out in space, and there are control towers set all around the globe. They control where those satellites are at any given time. So there are about 20 satellites that read the information from the satellites. There is only one. It's in Shriver Air Force Base out in Colorado. That is the only one that sends information back to the satellites to correct it. Okay, for mapping purposes, it is recommended to have at least 5 satellites. If you don't have at least 5, you're not going to get a very good lock. So it is recommended you have 4 satellites for a 3D lock, 3 satellites for a 2D lock. But generally speaking, the more satellites you have, the better the accuracy you're going to get. Brian, can you please mute yourself? Thank you. Now, what we have right now, we have about 70 satellites available. So, again, the more satellites you have, the better the accuracy you're going to get. Now, let's think about the globe. Okay, we have 4 quadrants. So if you're standing out in the field and you say, okay, front left, front right, back left. And if you look at your surroundings and you say, okay, well, I've got a lot of things blocking these satellites. If you want the best accuracy that you can get, you need a view of all 4 of those quadrants. If one of them is blocked, you're not going to get the best accuracy. So that's the best way I can put that. Okay, so here we have some of the constellations that are available. These are the ones we use in the United States. You have GPS, that's the United States. You have GLONASS, that's the Russian system. Galileo, which is the European Union. And together we refer to them as GNSS. So anytime you see that term GNSS, just keep in mind it's all of the constellations, not just one. Okay, so on this slide, we have a bunch of different receivers you can see here. Now, you can see accuracies on the left, you can see the units on the right. When you use your recreational grade GPS devices, let's say it's a Garmin, it's a TomTom, they're only going to get, at best, an SBAS correction. And I'll talk about that a little bit later. So you're looking at 1 to 7 meters. So if you ever noticed you're driving down the road, and especially in Pittsburgh, which is where I live, you have a bunch of roads side by side. The unit may not know exactly where you're at, so it tends to bounce between the roads. Well, why is that? Because it's only accurate to, at best, 1 meter. You get into an urban environment, guess what? Now you're probably getting up closer to the 7 meter. So now it doesn't know what road you're actually on, so it bounces back and forth. And that's the reason that unit does that. Now, you get into some higher end units, they have better corrections available, and they're just better receivers, and they don't jump as much. So they'll actually put you in the same spot that you're standing. So not all receivers are designed the same. So you have to keep that in mind. If you're looking for a particular level of accuracy, you might want to go with a different unit. Okay, so on the last slide, I listed here an SBAS correction. What is that? That is called a satellite-based augmentation system. These are the SBAS systems that are available across the globe. So these will give you much, much better accuracy. And the reason for that is these satellites are stationary. So they sit there, they cook, they collect information, they send it to other satellites and then rebroadcast it to you. It's highly recommended that any unit that you get, make sure it is SBAS corrected, because that's going to get you to the sub-meter accuracy in some cases if you're in the wide open, but not in all cases. So if you're not in the wide open, we're going to get into that later, you may not get that good of accuracy. So satellite signal is based on line of sight. If you get out of line of sight of the satellites, you're not going to get that good of a correction. So when you get under tree canopy, you get next to buildings, your accuracy is going to degrade. Okay, so how do we apply a correction to a signal? Well, you think about it, the signal's coming through the atmosphere. Well, the atmosphere will distort that signal. It will warp it, it will change it, and your accuracy really goes down. So how do we correct that? There are base stations set up, and in most states, it is set up by the Department of Transportation. So they put up a base station on each of their buildings, and those base stations, they calculate the position, very, very accurate. They see the information coming from the satellite. They calculate that and say, okay, well, this satellite is off by this much. Now, I'm out in the field, and I can say, okay, well, I want to tie into that base station, figure out what that correction is. Now you have the capability of going down to sub-foot and even possibly centimeter level accuracy. But without a base station, it's not possible, because you're moving around with your rover. There's no way to calculate a perfect position. So you have to have a base station. Okay, so here's an example of a base station network. This is actually in Ohio. They have one of the best base networks I've ever seen. And so they're stationed perfectly. The one thing you don't want to be any more than 16 to 17 miles from your closest base station. When you get farther than that, your accuracy degrades greatly. So here's an example. This is a network in Ohio. You tie into this network via an internet access. So you can do it from your phone, you can do it from a tablet. However you want to do that, you tie into your closest base stations and it gives you a correction. Okay, so one thing you want to avoid, and I hit on this a little bit earlier, if you have an obstruction, so let's say you have your receiver, you're out in the field, and you take a look around, what's in the way? Do you have mountains? Do you have hills? Do you have a building? GPS signal cannot go through an obstruction. So you have to keep that in mind. When you're looking around and you say, okay, well, why is my accuracy terrible? You may have something in the way. So take a look around, and maybe you have to move that receiver just a little bit to get better accuracy. So in this example, you see here on the left-hand side, there's a satellite on the left that's being blocked by the hill. That is going to affect your accuracy greatly, because now we only have 3 satellites rather than 4. So keep that in mind. Anytime you collect GPS information in the field, you have to be aware of your surroundings at all times. Okay, so here, you may not actually know this is happening. So there's something called multipath. Now, a GPS signal comes from a satellite. That's a radio signal. Radio signals are affected by a number of different things. One is a building. If you're standing right up next to a building, that signal could reflect off of the building, which is going to take that signal longer to reach you, which is going to give you a wrong solution. So you have to keep in mind anything that's around you. If you have a reflective target, that signal may bounce and you're not going to get a very good solution. Now, under tree canopy, you have two problems going on. That signal could be reflected or it could be bounced back completely. So you have moisture in trees, and what happens is when that signal hits the moisture, it gets reflected, and you're going to come up with an imperfect solution. Okay, and again, I touched on this earlier. What happens is when the signal comes through the atmosphere, it gets distorted by the moisture in the atmosphere. So you can account for that by using a base station. Again, you can either use that in real time or you can post-process after the fact. Okay, any of you that are currently using a GPS GNSS solution, there are some recommendations that I can give you. You always want to keep the receiver at the same height and orientation. So you don't want to lay it to its side. You always want to keep it pointed straight up. That's going to give you your best solution. If you have to head into an area, let's say you go from a wide open area, you're going into tree canopy, you may want to turn that receiver off because you don't want to collect that information. It's bad. And then when you get to the other side, you can turn it back on again. You never want to cover the receiver. So don't put anything over the receiver. Again, don't put it to your side. And that's going to give you your best solution. Make sure that that thing always sees open sky. You're always going to get the best solution that way. Okay, so this is one of our receivers. It's called the MLID RS2. Now, for any of you that may use Trimble units, you use, there's a number of manufacturers out there. But this unit is actually capable of centimeter level accuracy. And it's only $1,900. For any of you that use Trimble units, to get centimeter level accuracy, you're paying about $10,000 to $12,000. Okay, this is a much better solution. So you get 22 hours of use on one charge. It has a 3.5G modem built in. So now you don't have to use your cell phone. You don't have to use your tablet. You put a chip in this unit, and now you have a correction in the field. No phone, no tablet. The price on this is insane. I've sold GPS for about 10 years, and I have never seen a price in this category. I mean, it's insanely cheap. So if you need that sub-foot to centimeter level accuracy, this is the best unit for you. Okay, we have another unit called the Geoid. Now, this is sub-meter in real time, no correction. Now, this unit will achieve sub-foot in real time without any correction. So you don't need an internet connection, no phone, no anything. It will get sub-foot correction. The Geoid is sub-meter. So you're looking at about $1,600 to around $2,500, depending on what you want in the unit. But it will get sub-meter accuracy. I've tested it in the field. I've gotten about 1.5 feet, no correction, no internet correction whatsoever, 1.5 feet. Okay, we also have some mapping solutions that are available. So RD Map, it's free. You can use it with any of our RD locator units, and it will tie together the GPS information with the locator information. You can then send that from your phone. You can say, hey, I need to email it to this guy. You type in his email address, you hit the button, it goes out. So now all that information is recorded. We call it a cover your butt situation. where you're out in the field, you want to make sure you get it recorded, you send it to your manager and you say, okay, well, here's where I was and this is what I was doing. Now for the PUC, that's also very, very important. So in Pennsylvania, this is only for Pennsylvania, the PUC has taken over all of the fining for utility locating. So if you mismark, they're going to send you a fine. Now you can back yourself up and you say, okay, I was out there, I recorded all this information, and this is how I did it. You've just covered your butt. Not a bad option, and it's free. Okay, there's also another solution called Point Man. You pay for this, but again, you can tie together the information from the GPS receiver and your locator receiver, store that information, you have it in a spreadsheet, you have that information. Now, it's kind of a mapping system, but it's not great at that. So again, it's more of a, okay, I was here, this is what I did. Another solution called Subsurface Maps. Again, this works with all of our RD locators. You can tie together the information from the GPS receiver and from the receiver from your locator. Now, in this solution, you have unlimited data, photo, and video support. So if you're out in the field and you say, I want to take a video of this, you can do that. It will store it, and then you can pull it back at any time. Okay, so for those of you that do not have a GIS system, this is a great solution. So one cool thing about IMGIS, they price it based on the size of your utility. So if you have, 40,000 customers, it's going to be more expensive than if you have 20,000. So they kind of parse it out based on the size of your network. But this is a full functioning GIS. You could take the information that you recorded and you could take somebody's email, punch it in, and you can give them access to the maps that you have. So it's a really good system, and especially a great system for nobody that has a GIS. So if you don't have a GIS system right now, this is probably the best solution for you. It's going to be cheap, easy to use. You can have multiple users on this network, so you can share information. So if I have Joe out here and Gary out there, if he records information and he records information, they can share it in real time. Okay, for those of you that aren't aware, I mean, we offer all kinds of locator options. So we have low cost options, we have high cost options, depending on what it is you're looking for. We also have marker ball options. So for those of you that aren't aware, all of our locators come with a marker ball option. So you can put this foot on the bottom and it'll be able to locate these marker balls. Marker balls are great for situations where you can't locate the line. Maybe it's a T, you want to mark that out. Maybe it's a plastic line. You can drop these marker balls in there and you can go back and find those. We also have pins. You can drop these pins in the ground. You don't have to dig. You can just push them in and you're good to go. Okay, we also have all of the Jameson lineup. So we have live tracers, which some of you may not be familiar with this. When you get into a situation, you've got a water line, you've got a gas line, you need to trace that out. Well, I have no way to do that. It's a plastic line, no tracer wire. What do I do? You can go to the service line and you can hook up a live tracer. It'll hold back 125 PSI. You put that on the service, you fish the line down through it, trace it, pull it back out, turn the service back off, and then reconnect it. So it's an option you have available to you. Okay, we also have crawler cameras, and we have push inspection cameras. So if you're looking to do inspections, these are some great options available to you, and they're not very expensive, I'll admit. I mean, they're pretty cheap. Now, you get into a situation where you have a plastic line, no tracer wire. I have no other way to locate this thing. I can't put a live tracer on it. I don't know what to do. How do I find this? Ground penetrating radar is your best solution at that point. Ground penetrating radar will find anything in the ground. I don't care if it's concrete, clay, it can be metal, it can be plastic, whatever the utility is. Ground penetrating radar has the capability to find that. Now, it's not for everybody, I'll admit that. It's not a yes or no tool. There's a little bit of thought process that has to go into it. You look at the screen and you say, okay, well, I think it's here. But it's a lot easier to use than most people think it is. So if you run into that situation where you have non-metallic utility line, no tracer wire, I highly recommend you take a look at ground penetrating radar. Okay, soft dig situations. We all run into that. You're not allowed to dig, you're not allowed to use a shovel, you're not allowed to use a backhoe. What do you do? Okay, well, you can call a water excavation company, but now you have a giant hole in the ground that was dug out. You can't put that soil back in because it's wet. It's in the truck. You don't want to use that soil. We have a solution that uses air. So you use a tow behind air compressor. You can use both the air spade and the air vac on the same air compressor. You dig that hole out. Now you can dump that soil right back into the hole. No fuss, no muss. Works great. So if you guys have any questions on this, we can send you information. Okay, we also offer, for anybody that's in the gas industry, we offer remote monitoring solutions. So again, if you have any questions on this, these product lines, we can get that to you. And again, I told you I would keep it short and sweet. So that's what we have. Does anybody have any questions?
Remember, folks, you can type them into the chat, or you can just simply raise your hand. Or you can unmute yourself. I mean, we've got a small group here right now, so if anybody does want to pop in, go right ahead. We'll manage that.
Jeremy, first question. I use an app on my cell phone for elevations at fire hydrants, and I use that for leak locating. How accurate is that information approximately?
So what app are you using?
I don't know off the top. I got 3 of them that I downloaded, to be honest with you. I'm not sure which one it is at the moment.
So when it comes to elevation mapping, you have to have what's called geoid modeling. So if in the app it doesn't specify that there's a geoid, your accuracies are about 120 to 140 feet off. So that is the key. If you don't have a geoid model programmed into that app, your accuracies vertically are going to be horrendous.
Thank you.
You're welcome.
We have another question. Jeremy, can you explain post-processing?
Yes, so not all manufacturers offer this. So there has to be a software program on the back end where you can record your information, you store it, then you bring it back in, you download it, and you can process that against the closest base stations to where you were recording. Now, Trimble has that capability. Trimble is kind of like the premier of GPS providers. They offer that. There's also an Opus solution. So if you have a survey grade receiver that receives L1 and L2, good signal, you can send that in. They will process it for free, send it back to you, and now you have a post-process position. If you have more questions on post-processing, it can get pretty complex. Please email me directly or call me, and I can explain that to you in better detail.
Another question here on the MLID RS2. What does the MLID use as a controller? You mentioned you don't need a phone or a tablet.
So you can use it standalone. So you just go out in the field, you record your information. It's going to be about sub-foot. So you're going to be 3 feet. You know, you're going to be sub-meter, so 3 feet or better. If you're in a wide open scenario, so you're out in the middle of a field, it's going to get about 14-inch accuracy, 12 to 14 inches, roughly. If you apply some type of correction to that, so now you have tied it to your cell phone, you're using a control software, you tied it to the internet, now you're looking at anywhere from 1 centimeter to about 2 inches. But yeah, you can use it real time, no problem, and get sub-foot. I mean, it is possible, but you want to be in wide open conditions. You don't want to be under your tree canopy or next to buildings.
But you still need some sort of interface to get info off of it, obviously.
Yeah, so if you want the information out of it, you would want to use one of the software programs that I talked about. So you could use the RD map, you could use IMGIS. It depends on how much information you're looking to get out and what you're looking to do with it. So there are certain software programs that are free. There are certain ones you have to pay for, but you get more capability when you pay for the paid software. So it just depends on what you're looking to do with the information on the back
All right, hopefully that Kelly, that answers the question there. If not, we got the email as well. Another one from Dave Kimball. The remote portable reference point, does that have to be set on a physical marker of some sort? Also, does VA have that internet connection network for GPS correction, or what can I Google to find out about it?
Okay, so for Virginia, I'm not too familiar with Virginia. West Virginia, it's free. Pennsylvania, it's paid. New York, you have to pay for a subscription, and New Jersey, you also have to pay. So it's about $3,000 a year you have to pay to get that correction. Is it worth it? Yeah, because you can get much better accuracy on your GPS points. Now, when it comes to, so the MLID receiver, let me refer back to that one. You can get it in a kit where it comes with 2 units. What you can do is you can take one of the units and you put it over a point. It doesn't have to be a known point. You just have to keep awareness as to where that point is. So mark it on the ground with a flag, with some kind of marker, and you let that thing cook. So you sit it down, you let it receive information. It's got 1.5 gigs of internal memory. So it sits there and it records that information. You then take that information, you send it into Opus, which is the solution I just gave you. You take a file, you send it into them, they correct it. They give you back that file, you program it back into the receiver, you can put it back over that same point, and now you can use your rover device to go out away from that. And depending on the receiver, you can usually get about 1.5 miles away, give or take, and still be able to get a correction from it. It all depends on how high you have it and how good the antenna is you have on it, because it's working by radio frequencies. So if you go up and over a hill and drop down on the other side, guess what? You're not going to see that signal anymore. But no, you don't have to be over a known point to be able to get good accuracy.
Okay. Just back to Kelly there. I said there is software for the RS2, correct?
Yeah, that is correct. There is a control software that you can use on your phone, on a tablet, on a laptop. So it works across the board. It can be Android, Windows, or iOS.
Excellent. Okay. I think that's it. Oh. What is recommended for working in places like Manhattan with tall buildings and parks and trees?
What I can recommend to you is good luck. So when you get into that situation, you've got buildings on both sides. Now you can only see satellites that are that way and this way. So it's going to hinder your accuracy greatly. So anybody that's ever used a navigation device, a GPS device you program in your car, you get into an urban environment, what happens to your accuracy? It drops. It doesn't know where it's at. It's putting you on this road, that road. It doesn't know. And the reason is you can't see that signal from the satellites. So there's really not a whole lot you can do there. Now, some antennas are better than others, but when you get into that situation, I mean, your accuracy is going to be bad regardless. There's not a whole lot you can do about that. Now, some receivers, so the Trimble, I'm trying to think what it's called. So there is a device from Trimble where it has an offset function where you could stand out away from the target and then you can shoot it with a laser. And that'll give you better accuracies. But other than that, I mean, there's not a whole lot you can do there. So again, GPS works by line of sight. You don't have line of sight, it's not going to be real good.
Okay. Next question. I'm typing that in the answer here. Dave, yes, this session will be viewable on our YouTube channel. Just simply search Eastcom Associates on our YouTube channel. Next question here. Does RD work with the Leica units for GPS mapping?
Does RD work with the Leica units for mapping? I guess I need a little bit more information to answer that question.
Is Leica a GPS product?
Oh, okay. I see where they're going. Okay. Yes. So if you use RD Map, which is that free program, you can also pretty much use any of the rest of the software solutions. So our RD products, we really don't care what GPS device you use. You can use anything. You can use Leica, you can use Trimble, you can use any of the ones that we mentioned today, and it will still tie that information together. So the one key thing that you have to keep in mind, you have to make sure your GPS receiver is NMEA capable. NMEA. That is the National Maritime Signal. It's universal between all receivers. If you don't have that signal or you can't put it out, it's not going to work. So you have to make sure, go to your manufacturer and ask them, is it NMEA capable? If it is, then yes, it'll work.
All right. Yeah, and that should Bluetooth to the RD as well.
Yep.
Yeah. Next from Dave, couldn't you use the remote units on a rooftop to improve that accuracy in urban environments?
Yes, absolutely. But the problem is you put it on a roof, that's not the position you want to record. So if the receiver's on the roof and you want to record something down on the road, you're going to be off. So again, you could use a laser rangefinder to, offset that position. But generally speaking, yeah, you put it on the roof. I mean, it's not in the right place.
Okay.
So, I mean, that's the short and simple answer.
All right, any other questions? A lot of good feedback here, a lot of questions.
That either means I did a really good job or a really bad job.
Sorry, David, you want to clarify? So it's just a correction device for GPS, not a reference point.
Correct. Yep.
Okay. All right. Well, if anybody does have any further questions, again, we are available. You see our email up there, sales@eastcomassociates.com. That'll work for you. That'll get to the right person. Or Jay Somerville. Kelly, thank you for the feedback. Really appreciate everybody's time today in meeting us on this for this session. We have a few more sessions coming up. Tomorrow, we're actually doing one on ground penetrating radar basics. We're actually going to have Ken Wright with radio detection coming in and speaking with us there. So if you're interested in that, just check our events calendar at eastcomassociates.com. Also, next week, we are going to be starting a 3-part series of the locating fundamentals for underground utility locating. This is basically our big program split into 3 modules over 3 days. So hour sessions over 3 days, 1 per week. Again, more information on that is on the website at eastcomassociates.com, or you can just shoot us an email if you're interested in that. And again, thank you everybody for joining us today. We look forward to seeing you next time around. If you have any questions or you have any needs, we're here for you. Thank you.
Thank you.